Here is another example about this another example solving by using a superposition theorem. So here he asked us find Ix by using superposition theorem. So Ix is right here, the current passing through the 2 ohm resistor, and we have a 10 volt independent source, 3 ampere independent source, and 1 dependent source. We know that superposition theorem, we need to solve the circuit based on the number of independent sources. So here I have 2 independent sources, so I have to solve the circuit 2 times. So step 1, I'm going to keep a voltage source and replace the current source with its internal resistance, and keep the dependent source as it is. So I have to keep the dependent source as it is. So here I'm going to keep the 2ix or dependent source as it is, and I'm going to call the ix as ix prime because I have only one source. The current source is going to be open circuited because internal resistance of a current source is infinite, and internal resistance of voltage source is 0. When we replace the voltage source, replace it with short circuit. So here my goal is finding ix prime. It's just a single loop, so -10. I'm walking from here, reach the same point without touching any element more than once. That's just applying KVL. So apply KVL in the loop. -10, I'm entering through the negative terminal, so take that as a minus. Here I should have assigned positive and negative signs based on the current flow. So ix prime is entering, we always take that as positive because a resistor never generates voltage. So that is the reason I assigned positive there. This is positive and negative. So -10 plus 2ix prime plus 1ix prime plus 2ix prime. Okay, so 5ix prime equal to 10, ix prime equal to 2 ampere. So this is our ix prime. Now step 2, here I'm going to have again I'm going to find this ix double prime here. Ix double prime equal to, again I'm going to replace the voltage source with short circuit, and I'm going to keep back the current source 3 ampere. So here I use the nodal analysis. So at Vx applied the KCL, I1, I2, I3, I always assume every current is going out. I1 plus I2 plus I3 equal to 0. I1 is nothing but Vx over 2, and I2 is nothing but -3, and I3 is nothing but Vx minus 2ix prime. The voltage at this point must be 2ix prime or double prime, ix double prime. So Vx minus 2ix double prime divided by resistance value, that value equal to 0. Now I'm going to multiply this with 2. So Vx minus 6 plus 2Vx minus 4ix double prime equal to 0. Now ix double prime is same as negative I1, which is Vx over 2. So basically ix double prime is negative Vx over 2. I'm going to substitute that in there. So that will be this will be Vx minus 6 plus 2Vx plus 2Vx. Okay, we'll end up with 5Vx equal to 6. Okay, 5Vx equal to 6, Vx equal to 1.2 volt, and ix double prime equal to negative Vx over 2, which is negative 0.6 ampere. That's what I found it there. So the total current ix equal to ix prime plus ix double prime, which is 1.4 ampere. I'm going to solve another example with a dependent source here. So here is the next example. There are 2 independent current sources. One is 6 ampere, another one is 4 ampere, and there is one dependent source. Since there are 2 independent sources, we need to solve this circuit twice. So in step 1, I'm going to keep 6 ampere source, replace this current source 4 ampere current source with open circuit. Okay, it's open. current source always open circuit, voltage source always short circuit. Now our goal is finding Ix prime. So at Vx apply KCL. So Vx minus 0 divided by 2, I1, I2, and this current is I3. Vx minus 0 over 2 minus 6 plus Vx minus 4 Ix prime. So the voltage at this point, we have a dependent voltage source. So Vx minus 4 Ix prime divided by 8 equal to 0. So after solving this, I end up with 4 Vx minus 48 minus Vx equal to 0. End up with Vx equal to 16 volt. But at the same time, our goal is finding Ix prime equal to X prime equal to Vx over 2, which is 16 divided by 2, that is 8 ampere. So I found current flowing through these 2 ohms because of the 6 ampere. Now the second one is, I'm going to keep the 4 ampere, replace the 6 ampere with the open circuit. So here I'm going to take this as a ground, node at that point as a ground. So this is the ground and this is supplying, and I'm going to label this as Vx. Now at Vx I can apply KCL. Actually that didn't work, so what I'm going to do, I'm going to do the loop analysis. So the loop analysis, I'm taking Iy current is coming in or anti-clockwise direction, Ix double prime is also anti-clockwise direction. So I'm going to use the super loop analysis in this case. So I'm going to start walking from here and come back to the same point without touching any element more than once. So 8 Iy plus 2 Ix double prime minus 4 Ix double prime equal to 0. So I end up with 8 Iy minus 2 Ix double prime equal to 0. This is my equation 1. Now my equation 2 is going to be always super loop. We always end up having 2 equations. So another equation is, you're saying Ix double prime is going up and Iy is coming down, and the resultant current is going up. So Ix double prime minus Iy equal to 4, Iy equal to Ix double prime minus 4. So I have 2 equations. This is my second equation. Substitution method, I think I used substitution method here. I found that Ix double prime equal to 5.33 ampere. So the final answer to find Ix equal to Ix prime plus Ix double prime. So 8 plus 5.33, the final answer is 13.33 ampere. I'll stop this video here. Thank you.